Greetings everyone, I hope you guys are doing great and are taking good care of yourselves. Welcome to this video. It has been a minute and honestly I did not have a video topic for this week, but I have a list of video topics I want to talk about, and one of those videos I want to make is one about WebSockets, which is the one that you're going to actually watch. I'm going to be explaining what WebSockets are, how they are different from traditional HTTP requests and responses, and why we may need to use WebSockets instead of using the traditional HTTP requests. We're also going to be building some simple WebSocket servers, and that will help us to understand how, in theory, these WebSocket servers work. We shall also implement some WebSocket clients for different simple applications to just show different topics. So I hope you guys enjoy this video, and I hope you guys find value out of this video. So without wasting your time, let us just jump into that topic. For us to appreciate WebSockets, I'm going to begin with a very simple example of a Fast API server right here. So this is a simple REST API that we've built with Fast API, and all it's doing is to expose a root URL right here to be accessed via the GET method, and then we trigger a handler which is going to return this response of Pong. So this server is running on localhost 8000, or it's actually running on any accessible IP address, but on port 8000 of our local machine. So what we want here is to be in position to make a request, and then the server will return a response. If you want to go ahead and access this, I'll control and click on this link, which will then open up a client or a browser to make the request, but you can even access this using a client like Postman or Insomnia or anything else. But for now, all we're having is this simple response being returned right here. But under the hood is quite a lot of other interesting things that are actually happening. And to know what is happening, the browser gives us access to developer tools that can allow us to see what exactly happened. So if I go to our browser development tools, I can go to inspect. And when I go to inspect, I can go to network. And inside network, I can see this specific tab right here. So what this allows me to see is information about the requests that I made to access a specific page, or basically get the response from whatever server I made the request to. I can refresh, and once I refresh this time, I can be in position to see things such as the request I made to that particular IP address. So if I click on this, I can see things like headers, the preview, so this will return the response from the server, the response itself, initiator data, timing, and so on. But what I'm interested in is the headers, which is basically information about either the request or the response. And this is always determined by the client, which is going to specify all these headers when sending the request, or the server that is going to then return all these with the response. So yeah, this is the information that the server is going to return with a response, and then this is this information that the browser is going to send with the request to the server. But what is going to happen is, when the browser is making the request to the server, it has to specify a URL, a method, which is in our case get, but this can be post, put, patch, delete, and so on. And then sometimes when you are making, like, let's say a post request or a put request to update something, you'll be sending a request body, which is going to also be part of that request. For now, all you're doing is a simple get request. So when you send this request to the server has to process that request, send us a response, and then return the status code plus other response headers. So in our case, the response headers include the content length, which is 18 in this case, and then the content type, which is application stroke JSON. We have a date to show us when the response was returned, which is this date right here, as well as the server that sent back this response. So for our case, that is UVCon, because we, of course, are using the Fast API CLI. Next, we have the request header. So this is information about the request as sent from the client. So we have all this right here. And all these are sent with a request when you are making that request. The idea here is to just explain to you how a request is sent from the browser to the server and what exactly happens. To demonstrate that in detail, I have a simple screenshot I grabbed from the WebSocket handbook by the guys at Ebly. I'll link this book down in the description for you guys to read it. It's quite an interesting book about WebSockets and how they work, and it goes so much more in detail. So during a normal HTTP request, just like we've done in the previous example, we have a client and the server communicating. But what happens is the client is going to make a request to the server, and the blue line right here is going to represent the connection between the client and the server. Once the server processes the request and then returns a response, the connection between the client and the server is always going to be terminated. So that means that in HTTP, every request that we make to the server creates a connection that's going to be destroyed when the server returns the response, which is different for WebSockets, because in WebSockets, what we have is a handshake happening, which is kind of like a request. And when that request is happening, the connection is going to be created. The server is going to acknowledge that handshake, and when it acknowledges that handshake, information can then be transferred from the server to the client or from the client to the server for as long as that connection exists. So what we have here is a persistent communication between the client and the server over a single connection that is established between them. And for as long as this connection exists, the client and the server will be in position to share information until maybe if the server disconnects or the client disconnects. And that's the beauty about WebSockets. Now, I know I've talked a lot, but for us to understand this, I'm going to have to build a simple WebSocket server with Python. And I hope you enjoy what is going to happen. I'm going to start with a very simple blank folder right here, and what we're going to do is to go ahead and basically create a virtual environment. Now I'm using UV to create my virtual environments, and it is really fast in the way it works. So if I wanted to create a UV virtual environment with venv, all I have to do is UV venv env. I think I'll just have to create a separate video explaining UV, but it allows me to use the same venv workflow I'm used to from Python-mvenv. So once I've created a virtual environment, it exists within our folder. So to activate it, I'll do the normal source env bin activate. And once I've done that, I can install packages via uv pip install, because that gives me access to pip. So once I have that, I can go ahead and install the WebSockets library, which is the most popular library or package for implementing WebSocket clients and servers in pure Python. So what I'll do is to go ahead and install that, and once it is installed, I can then pip freeze it to requirements or txt file with uv pip freeze, and then I point to that file right there. And once that is done, I can then ls, and just to see the contents of our requirements, so txt, we have our WebSockets installed. Now, once we've done that, let's go ahead and create a simple file right here. I'll just touch app.py, which is going to be the file in which our file is going to be, or our server is going to be built. Now, we're going to be using mainly asynchronous code. So I'm going to go ahead and import async.io. Async.io is basically the library that's built in Python that allows us to run asynchronous code. So we can implement functions that have the async await syntax, and those are coroutines. Async.io comes with a function called async.io.run, in which you can specify the call to such functions. Now, I'm going to be implementing a function called main, and this is where our WebSocket server is going to run. So I'll define a function called main with async def main, and then in here is where our server will run. But before we actually go ahead and write our server, we have to first of all define how we're going to handle all the WebSocket connections. Now, to handle all WebSocket connections, you'll have to define the function that's going to handle them. So I'm going to define a function here. I'll just call it the WebSocket handler. and this is going to take in a WebSocket object. Now, instead of thinking of this as the WebSocket, let's think of it as the connection that is going to be in between the client and the server. And this connection is going to be independent, or it's going to be unique depending on each client that's going to connect to the server. So for now, let me just print the ID of each WebSocket connection. Now Python, or the WebSockets library, allows us to basically add UUIDs that uniquely identify each client that's going to connect to the server. So if I do something like print WebSocket ID, that will go ahead and print the ID of the current WebSocket that has connected to the server. To serve this function, I'll then have to go ahead and implement the serve function right here. Now, since I'm using async APIs, I have to go ahead and access a function from the async IO implementation of the WebSockets. So I'll do something like from WebSockets dot async IO dot server. So this is the server implementation. I'll go to the serve function, and this serve function is what will allow us to expose this function right here on a port and a host so that clients can connect, or the server can listen to connections through that port and host. So to do that, I can use a context manager. So I can do something like with a sync with serve, and then I can provide first of all the socket, or let's actually hover over this. So one thing we can notice is that this takes in the first parameter, which is the handler, and that has to be basically a function or a callable or an awaitable that takes in the server connection, which is what we've defined right here. This is the coroutine WebSocket handler, and it takes in the server connection object, which is the WebSocket right here. So think of each of the WebSockets that we're going to provide here as the connection between the server and the client. Those are going to be uniquely identified by the ID. So this will just go ahead and print that and then exit. So we're going to come and provide that, and then we'll have to then provide the host on which you want this to run. So we can provide our local host. So that's exactly what I'm going to provide here, and then I'll provide a port. So let me just make this run on, let's say, port 8005. So I can even move this and say something like host, or host and port. I'll make these variables. So I can say host, port, and then hide these inside variables. So we can have something like host is going to be equal to localhost, and then we can have our port be equal to 8005. So that alone will be a call to our serve function. Now to create an object here, which is going to be called the server, and this server is what will go ahead and allow us to serve this, or expose our web server, or make it run. I want to run this until it is stopped, so we can call this serve forever function right here. So this is an alternative to using servers and asynchronous context manager. So this will only shut down in case we stop the server with Ctrl+C, and I'm going to be demonstrating how that will happen. So for us to run that, I can even add a print statement right here, and we can say something like WebSocket server running on. So when exposing servers, or when working with WebSockets, the way we define our URIs is going to be different from how we do it with HTTP. So when we're making HTTP requests, we always have to provide the URL using the scheme of, so I'm going to create a simple docstring right here. And in HTTP, we always have schemes that begin with HTTP -- or when we are working with encrypted connections, we have to do something like HTTPS. So with WebSockets, we have to work with WS or WSS for encrypted connections. And the beauty is that the way we encrypt connections using HTTPS is not so different from the way connections are encrypted when using WebSockets Secure. So that's just something to note. Now, when we're deploying our WebSocket server, this is going to be listening on a certain port if we do not specify one. So the ports for WS in our development will be default 80, and then for WebSocket Secure, that's going to be 443. That's in case we have not specified a port. Those are the default ports that our connections will be listened to from. So now we need to go ahead and basically provide that statement. So if I come in here, I can say listening on WSS, then I can provide the port. So actually I need to provide the host in here, colon the port. So that will go ahead and basically print out our print statement to show that our server is running. So let's make a very quick recap about what has happened so far. What we've done so far is to define a function that is going to handle our WebSocket connections. This function is called WebSocket handler, and all it does is take in a WebSocket connection object, which we've called WebSocket, or let's say this is a server connection object as defined by the WebSockets library. Each WebSocket connection or each web server connection is going to be identified by a unique ID, which we have access via ID. Now for this to work, we have to then serve that WebSocket handler and expose it on a certain host and a certain port. Using the serve forever function, we can then be in position to run the server until it is stopped. So now that we've done that, let us go ahead and run our server. Now, since I'm using UV in our virtual environment, I have to do something like UV run, and then I'll have to run Python 3 and then the app.py. So that will go ahead and run our server. But now I have some method I forgot to await. So I have to go ahead and call await serve or server.serve forever. So that's that small mistake I had done. So every time you see this runtime warning, enable trace malloc to get the object allocation traceback, the runtime warning of coroutine was never awaited. Sometimes you just have to check and see if you've awaited or forgotten to await a certain method. So that's exactly what had happened there. So if I go ahead and run, we can now see that our WebSocket server is running on that specific URL, but I think I've done a mistake in my if string, so I have to make this run like that. So if I go back here, stop the server, and then run, now we can see our WebSocket server is running on WS localhost 8000, which is amazing. For us to basically get an understanding about how this works, let us test it out using the WebSocket client that comes by default when you're using the WebSockets library. So to access that, I'm going to open up a new terminal right here, and this terminal is going to be one that we have to have in our virtual environment. So I have to be in the same virtual environment I've created where the server is running, or in another place where we actually have the WebSockets library installed. Now, when I run UV run, this is what will allow me to see the various commands that will come when I've installed the various Python projects or various project dependencies, or basically Python. Now what I want is this WebSockets command. So this WebSockets command is like the CLI that they provide to us to test our WebSocket connections. So I can do something like UV run WebSockets, and that will go ahead and tell us that we need to provide a URI. Now, since we are aware of what URI we need, we can just come right here and provide it. So I say WS and then localhost. This is going to be 8005. So since this is meant to go ahead and close, we shall see that our client is going to connect. And once it connects, it will go ahead and do whatever it does, and then the connection will be closed. But we see it's a clean closing. So that will be a 1000 response returned for OK. So that's exactly what we expect as a response from the server when there's a clean exit. So when you go back to our server right here, we're going to see the WebSocket ID printed right here. So each client is going to be identified by a unique ID. So if we do the same command once again, and do it once again, and do it once again, we shall notice that we are then printing multiple UUIDs. So all these are going to represent different connections to the server. Now let us do something a little bit more interesting. What if we wanted our WebSocket clients or server connections to do some interesting stuff, like let's say getting messages, or basically allow us to get messages that are coming from clients? So we can access some functions that can allow us to do that, and let's see how to do that. So I'm going to go back to our function right here, which is our WebSocket handler, and instead of just printing out the WebSocket ID, I'll change this, make it a string, and maybe hide it in a variable called WebSocket ID. So once I have this, I can then maybe trim it to access only the first 6 characters. And once I have those, then what I'm going to do is to basically make something like print an f string, and I'll say client, and I'll provide the client ID or the server connection ID. So I'll say WebSocket ID joined, or basically connected, and that will be just a simple print to show that the client connected. Next, I'm going to go ahead and access all the messages that are sent through the connection, and then I'll just echo them to whatever client sent or made the request. So to do that, we are going to use an async for, because this is like an async iterator, so we can access all the messages by using an async for loop. So I can say async for message in the WebSocket, or we can think of this as a server connection. Then we can basically use the same connection to send back the message to the client that sent it to the server. So you can do something like await WebSocket dot send. So this is a method that allows us to send a message, but keep in mind this message has to be in string format. So if we're sending something like a dictionary, we have to first stringify it before you actually send it. Now for our case, we're just going to go ahead and say send message, and that will be just enough. So this connection will be persisting, and then the client will be sending a message. The server will just echo back the message. So to see this take effect, I'm going to go to our server. I'll do Ctrl-Z to stop our server, and then I'll run it again to reflect our changes. Now, normally when I'm working with VS Code, I always have this problem where I run a server in the terminal, and then I'm told that the address is already used. So how I solve it is by simply using Ctrl-D to terminate that terminal session, and then open up a fresh terminal session. So I always have to make sure this virtual environment is created and running, and once it's running, then I can go ahead and run our server. So our server is running. Now let us connect some clients. Now when we connect a client, this time we're going to be presented with a prompt. So that's exactly what happens when WebSockets are expecting us to send some messages using the connection. We always have a prompt right here that will help us to send a message to the server. So let us send our first message to the server. We'll just say hello, and now we see that the message is being echoed back from the server. When we go back to our server right here, we'll see that it's showing that the client joined. So let's just make this a little bit more interesting. I press Ctrl-Z to stop our server, and then I will come right here, and what I'll do is to go ahead and simply print the message. So I'll say something like client WebSocket ID, and then I'll say says, and then I'll print the message. So this will be some sort of like in terminal chat application. So I'll do the same Control D things again. And then I will have to create another terminal. So our server is running, create a new terminal, and in that terminal run a client. So we have that. Now, if I send a message, server is going to echo back the message or the string we sent. And when you go back here, we shall now see the client joining and then the client saying hello. So that shows that in real time we are in position to get the message we've sent to the server because it's sending it back to the client. And this alone can allow us to implement some interesting chat functionality. But for now, all we are doing is to just send a message to the server and echo back to the client. So if I connect this other client, we shall see our server without restarting or without sending a response. It's just in position to show us that the client joined. And when we send another message, still we can be in position to see the message being sent. So now this is very interesting. We can be able to do some interesting things with just this. So in the next portion of the video, what I'm going to be doing is to build a client on the web that is going to help us understand how clients will handle these WebSockets, and I hope you gained value out of that. So at this point, what we've done is to basically go ahead and implement a simple WebSocket server using Python. This WebSocket server will get any client connection, print the ID, and then allow the client to get back the same message it sent. That alone can allow us to implement sort of like a WebSocket chat server. And let's see how that will happen. Now, depending on which platform you are working on, you are going to get a WebSocket implementation. So for this example, I'm going to be showing one with JavaScript. JavaScript gives us the WebSocket class that allows us to create WebSocket connections and call different or listen to different events on those WebSocket connections so that we can perform some functionalities. And that's exactly what we're going to be doing. To start, I'm going to go ahead and create a new file. This is going to be an HTML file. So let me call it index.html. Now I'm going to be rendering this using live server. So if I open it up with live server, which is a VS Code extension, I'll have my index.html opened up here. But you can feel free to open it up in any way you want. Going back here, what I want to do is to go and basically link this to a JavaScript file. So I can create a new JavaScript file right here with index.js. So that's where our JavaScript is going to be. And then I'll have to link it to this index.html file. So let me use this exclamation mark to create a boilerplate index.html file with some HTML code. So I'll call this our chat client. So once this is done, we'll now go ahead and basically create the script tag just near the closing body tag, and that's where we shall access our index.js. So once we have access to that, the next thing we're going to do is to go ahead and then create the simple connection to our server. But to test whether our JavaScript is working, I'll just go ahead and console log something like hey WebSockets. So that's going to be logged within our browser. If I go back here, inspect, go to the console, I'm not seeing any change. So if I refresh, and now see that our JavaScript is actually working, which is amazing. Now, since we have our client connected, I'll then have to go ahead and create the connection or the WebSocket object. So this will allow us to create the connection object, and then the server will automatically handle it using this function. So I'm going to close the app.py file. So how do we create a new WebSocket connection in JavaScript? Basically, what we need to understand first is going to be the URL that we need to make the request to. I can even just create this as a constant URL. So this is going to be our WS localhost 8005, which we've created on the server side. What have I done here? This has to be localhost 8005. And once we have that, then we need to go ahead and create a new object. So this is going to be our WebSocket object, and that is going to be a new instance of our WebSocket class. So this takes in the mandatory URL, which we've defined as our URL. And once we've provided that, we're now able to start our connection. Now when I save, this time I see our network tab is what I'm interested in. And when I go to our network tab, we have our index.html being fetched, we have our index.js being fetched, as well as this 101 response. So that's exactly what I'm going to go into details about. We also see the WebSocket kind of handshake happening right here, and this script is, I think, part of the browser extensions that I currently have. So yeah, when you make this request, it returns the index.html, a simple HTTP request and response. We get the page, which is okay. I close that. Index.js is the script we basically wrote for the HTML localhost. So we have this 101 request or response being returned from the server. It's actually a response from the server. And this is exactly what we meant by the opening handshake. So the handshake is a GET request that the client is going to make to the server. And when it makes that request to the server then has to respond with the acknowledgement of that handshake. And the response is going to be of a status code of 101, meaning it's switching from the HTTP which the client made to initialize that handshake to WebSockets. So once that is done, then WebSockets are created. Now the server and the client can communicate and share information in real time. So now we also have other headers. So we have the connection. So this is like the header that the client will send to the server, describing how it wants to upgrade the connection from HTTP to WebSocket. And then we have these other things like the date, the WebSocket accept, which is basically the response to the WebSocket key, and so on. If we're to look into that, we also see some things about the WebSocket version, where it was sent from Python and things like that. But what is interesting are the request headers. So in this case, we see the accepting coding, we see the connection. So this is like how the client wants the server to upgrade from HTTP to WebSockets, so which it does when it responds with connection upgrade. So it has upgraded to WebSockets. And we even see the host, which is localhost 8005, the origin, which is our WebSocket server. So actually this is the server, which is 127.0.0.1, which is on HTTP. So the request is an HTTP request at the start, but it's upgraded to WebSockets. And then we see extensions, the WebSocket key, the WebSocket version, which is version 13, and then upgrade and the user agent, which is the client that made that initial handshake. So things to note, the thing to note here is the client makes the request to the server, which is an HTTP request, and then the server will return a response telling the client that, you know what, we are switching protocols. So we are switching from HTTP to WebSockets, and then the connection or the communication between the client and the server will start. So yeah, that's basically what we are doing right here. If we go back to our VS Code, this new WebSocket object is what is allowing us to do that. Now the interesting thing is when we get access to that object, we can access it and be able to play with it and see its attributes. So if I say WS, I can see the WebSocket object we've created in our JavaScript and the different attributes it has. Now some of those are events like the onclose, the onerror, the onmessage, and onopen. And these are things we get to play with when we are executing codes during the different events that will happen. So let's go ahead and play around with those and see what they will give us. So if I go back to our JavaScript right here, I can say ws.on, and then you can see all these events being called. So I can start with onopen, which is basically one to help us execute code in case our WebSocket connection is open. In our case, we can write a simple R function right here that can take in an event parameter. And in here, we can basically go ahead and say that the connection has been established. So we can just go right here and say that the connection has been established. Now, since our connection has been established, we can even use methods, but let me not use them for now. I'll just have to just console log our connection has been established. So when I save, we expect that that is going to show that the connection has been established, meaning that we have successfully connected to the WebSocket server. Now let's also implement the WebSocket.onClose, which is one to help us execute code in case the connection is closed by the client. So in this case, we can come and say console.log connection closed. Now the next one is going to be the last one, which is not actually the last one, but it is the onerror, which is going to be necessary in case we have any error in the connection. So in this case, we can say event, and then we can console log we can make a console log showing the error. So in this case, we can say connection error. So if the server makes an error and there is no connection, then that is what is going to be console logged. So in this case, we can say connection error or an error has happened. So these are three. The first one is for when the connection is open. So this is an event that when the connection is open, or when the WebSocket connection is open, we can run some code when the connection is open. When the connection is closed, we can run some code when the connection is closed. When we get an error, then we can basically go ahead and execute some code. But then you have a special event, which is the one for onmessage, that allows us to handle what will happen when a message comes from the server to the client. And that's what we're going to be using here. So we can go ahead and console log the message. But for us to do that, we can come and say message. And then am I about to write Python in JavaScript? I was about to write an F string. So in this case, what I'm going to do is to just come right here and say event.data. So event.data will give us access to the information that is coming from the server. Now remember that we went ahead and basically made the server echo back the data that is being sent to it from the client. So in this case, we expect that when we send this message, it's going to be echoed back, and that's what we shall get in our console log right here. So if we go back to our client right here, we are only basically going ahead and printing out connection established. This is because we have not been able to send any messages. Now, when we go back here, we can see this is an event, this is an event, this is an event, and this is an event. The beauty is we can even use event listeners, or we can do the same thing using something like ws.add event listener. Then we create the event. So in this case, we see the 4 events: close, error, message, and open as the ones we can basically listen to. So if we wanted to implement the one for, let's say, open, we can have open and then implement the our function as a callback function here. We can just provide event and then run the code. So that's the code we shall be running for the connection being open, similar to what we did right here. Now, when you go back to our client and type our WebSocket object, we shall now go ahead and see that we have, these are events, but then we also have the different basically methods. The two methods we're going to have on our WebSocket object are going to be the WebSocket.send method and the WebSocket.close method. These methods are going to allow us to be in position to send a message from the client to the server or close a connection between the client and the server. Let's see how we can use them. So when you go back to our client code right here, we can go and send a simple message to our server just right where we get to open our connection. Now in this case, we can do something like WebSocket.send. So this is a function, and then this will take in data as a string. So we always have to make sure that the data we are sending is a string, and if you have any other data type, then we have to JSONify it before we actually send it to the server. So in this case, we shall just say connected, and this will allow us to basically tell the server that we have connected. So if I save, head back to our client right here, so you forgive me for this, we now see that our code for the message event is being called, and therefore we are logging a message that is being echoed back from the server, which is kind of interesting. So this means that we have been in position to send a message to our server, and then our server is responding with our message. So we now see that the server has told us that we have successfully connected. Now let us make this more interesting to implement some sort of like chat server. So what we shall do is to go back to our HTML. I'm going to speed code this, and all I'm going to be doing is to create a simple text area where users will enter a message. I'll create a message list where users will send or basically be able to see the messages echoed back from the server in real time, and then we shall see how different clients will look with the various messages from the server. So let me go ahead and speed code that. Now this is a simple markup I've built. We basically have a simple message list div right here, which is going to be where our messages will be displayed, and we have a simple div here with the ID of messages input, in which we are going to be sending the messages in this form right here. So for us to make this work, I'm going to go ahead and first of all select our form. So select our form, we're going to be using DOM manipulation to basically select it. I'll come right here and say const, this is going to be our form. Since it's the only form element existing within our entire document, we can do something like document.query selector, and then we shall specify the element to be our form. And once that is done, we can then go ahead and also select our messages list. So we shall come right here and say message list is going to be equal to document.query selector. So we can go ahead and select the ID of messages which we've created right here. So I'll go ahead and provide this. So I have to provide the hash, meaning ID, and then the name of the ID, which is messages in this case. Once this is done, the next thing is going to be for us to then handle what will happen when we submit this form. So in JavaScript, you can go ahead and call or listen to one event using the name of the element dot the method called add event listener. So this takes in the name of the event. In this case, we want to listen to the submit event of the form, and then we shall write a callback function which shall take in an event and then perform some actions in this callback function. Next, we want to prevent the form from being submitted when we are basically submitting it, or basically refreshing the page, because by default, of course, when we submit an HTML form, it has to refresh the page to send that data to the server, most especially if you're using a post request. Now, when I basically go ahead and call event or prevent default, the server that we've created right here, or the client, will be one. So I've created columns 3. I think I was supposed to say columns, which I actually wanted to say rows instead of columns. So that was a simple HTML mistake I made. So if I say rows equals 3, we have this simple input right here, and then we have this. So when we press the button, we are not refreshing the page, but if we left that out, let me say I commented it out, each time we press this button, we shall refresh the page. So e.prevent default is going to prevent us from submitting the form. Now, since we've been able to basically prevent the form from submitting, and our inputs are all wrapped inside a form element, we can get access to the form data API, which allows us to handle forms as long as we've been able to set up all the attributes. Now I'm going to create an object called the form data object, which is going to be a new form data instance. And what this is going to take in is the form element. So you need to have a form element, and once you have a form element, you can then access all the data via the name attributes you provide. So we want to access this message. Now once we've got that, we can call various methods, but if we wanted to access the message, we'll just have to come and say form data dot get, and then we specify the name of the name attribute you want to access. So that's going to be the message. So once we have the message, we are going to now go ahead and use our WebSocket object to send that message to the server. So we can come right here and say ws.send, and then this has to be a string, so shall say message. To make sure that our form resets or it is cleared, we can use the form dot reset method to go ahead and refresh or reset the form. Now when you go back to our chat client right here, we can type in a message like hello, send, and now we see that our message has been sent, but our input has been cleared. Let us look at what is happening in the console. So right now we see that the server has echoed back the message we've sent, and even when we go back to our server right here, we see our client connecting, and when it connects, we also see the message being sent from the client, which is then echoed back to the server and is console logged right here. So I want to perform something interesting. Each time we send a message from the server to the client, we want to be in position to see that message in real time on our client. So how are we going to achieve that? Since we selected our message list div right here, we can be able to create some HTML and dynamically just inject it inside that div. So to do that, I'm going to go to our WebSocket.onMessage input right here. But before we actually go there, let me first do something interesting in our server. I'll stop our server with Ctrl and Z. And once I've stopped the server, next thing is going to be to basically modify how we're sending these messages. Now, not we're sending a string, but we want to go ahead and add some nice metadata to the message. So all I'm going to do is to change our message. So instead of changing or sending the message data, this time I'm going to send an object called message data, and our message data is going to be a string, but this string is not going to be a normal string. It's going to be a JSONified dictionary, which we shall then read from the JavaScript side as an object. And how we're going to be doing that is by basically making use of json.dumps. Now I have to import this, but what json.dumps does is to stringify our native Python data type, and then we can be in position to access that from another programming language in either an object format or another format. But that data type has to be JSON serializable, otherwise that won't work. So at the top right here, I have to come and say import JSON. And once I've imported JSON, then I need to go ahead and specify what I want to dump. So the WebSocket message is going to be a string, but we want to go ahead and create a dictionary out of that. So I'm going to provide different things in here. So I'm going to create the client ID. So the client ID is going to be the WebSocket ID from the server, which we've called, of course, WebSocket ID. I need to also go ahead and provide the message. I just call this message the body of the message. So yeah, I'll provide that as a message. And then lastly, I'll provide the date time as date. And then, let me just say date time, let me just make it just sound like time. So when I provide that, I can then come in here and provide a datetime object, but in a string readable format. How do we do that? I can come right here at the top and say from datetime, I want to access the datetime class. And once I've created the datetime class, I need to come right here, datetime dot now, and I want to convert this to an ISO format date. So this will transform that datetime object into a string that has the date organized in a form of year, month, date, and then the time part will be in hours, minutes, second, and then microseconds in that format. So this alone is a message that we can send to the JavaScript part. And when the JavaScript part receives this message, it will be in position to kind of pass it and turn it into a native data type that it can understand. So if I start our server again, I'm now seeing that the address is being used. So I'll try to open up a new terminal this side and run our server again. So our server is running. I'll stop this terminal right here and then go back to our client. So if I go back to our client right here and refresh, this time I will see a connection established and connection closed. So there may have been an error on the server side. Let's have a look at our server side. Cannot access local variable message where it's not associated with the value. So we have an error occurring on the server side. Now let us look at what is exactly happening here. I am creating this outside the scope of the for loop. So I need to go ahead and just add it to be part of the scope. And when I fix the indentation right here and fix the indentation a little bit, we shall have our message data being created inside where we declared the message. So if I stop the server with Ctrl-Z and run the server again, it's kind of annoying how I have to repeat this entire process. But if I go back and run the server, go to the client, refresh, this time we shall see that our client is now in position to access the message sent from the WebSocket server. Now, how do we pass this message? Remember, in JavaScript, we have APIs that allow us to deal with data that's coming in terms of JSON and pass it into data types that JavaScript can understand. Now, this right here is a string, but we can read it as an object in JavaScript using the JSON.pass method. So I'm going to go back to our index.js right here, and where we get messages, I'm going to create a variable called the event data. Now this is of course going to be equal to event.data, but I want to make it different because we want to JSONify. We actually want to turn it from JSON into something that JavaScript can understand, which I'll say not JSON.dump but JSON.pass, and then this will be the event.data. So rather than printing the event.data, this time we shall print the event data, and when I save, I'll go back to our client, and now we have a JavaScript object with all the data that we need. So we can be in position to use this to populate our DOM or to inject our DOM with new information from the server, which is interesting. So let's go right here. In our index.html, we just currently have a blank messages list. So let's create some dynamic HTML right here. So I'm just going to come right here and say that we're going to have message. So let me just say const message is going to be equal to a string. Now I'm going to be using template strings, which are basically like f strings in Python, where you can have a string, but you can inject in variables however you want. So this is going to be normal HTML. I'll create a div and a closing div tag. And then this div will have some interesting things in it. So what I want is to have, let me actually make it readable. So I'll have this div and it will have a class of message. Let me just focus on the functionality for now. So this will have the client and then the client ID. So since we have the event data, we can access the event data dot the client ID. So I can access the event data. When I go back here, I have this client ID. So that will give us the client ID. So if I say event data dot client ID in this $sign and curly braces, this will inject that value inside this HTML right here. But remember, this is a string, so we have to inject it into the blank messages list. And how we're going to do that is by basically coming right here and saying message list, simply because that's how we selected it from the DOM. We will have to append to the inner HTML by just saying plus equals, then shall append the message. So yeah, this time when you go back here, we now see the HTML being injected. So we have the client and the client ID, which is interesting. So let us now add the message. So we can maybe make this bold. This time we see our client connected, which is interesting. Now we want to go ahead and I think I forgot to close this. That's why everything is bold. So when I change that, we have this client, this connected. Now to get this date time and then show it down here. So to do that, and then I'll just get the date time, convert it to a JavaScript readable time. So how am I going to do that? First and foremost, at which we are basically getting to connect. So that's interesting. We've so far been able to show that the client has connected. Now let's use our input right here. If I send a message, then server echoes it back and we can see it in real time, which is amazing. Now let us go back this side. We can introduce a separator, which is, let's just say, an HR tag, and maybe a BR to just space things a little bit. So yeah, that's going to be our message right here. And if I go back to 100, this is how everything is going to look like. So send a message to the server, get a response, and that is going to be our WebSocket. So let us create another client. If I go ahead and try to create another client, I'll just put this right here. This is a client right here, so it creates its own connection and the messages are not going to be seen by this client. So if I refreshed, this is going to be its own client, but when I send messages here and send, it's only this client that will see messages that will be sent through its connection. Those messages will not be seen by the other client. So this client will send its messages, but its messages will not be seen by the other clients that are connected. Now the reason as to why that happens is because these are different connections. This client is making a different connection and this client has its own different connection. For us to achieve some kind of like real-time chat functionality, we'll have to use broadcasting on the server side. So broadcasting will allow us to get our WebSocket clients that are connected to the server and then send the same message to them. Think of it as just grouping all the WebSockets inside an iterable, like a list, and then running a for loop where the for loop is simply sending a certain message to each of the clients that are connected or part of that iterable. To see this in action, let us go ahead and basically use that. So to go back to our server right here in app.py, I am going to go ahead and stop it with Ctrl and Z. You can see the different connections right here and the different messages that are sent by the clients, which is amazing. In this case, if I go ahead and run, what I need to change is how I'm sending this message right here. Instead of sending it, I want to broadcast it to clients. So yeah, let's see how that works. So to begin, we're going to first of all import that method. It's not actually a method, it's a function from WebSockets.asyncIO.server. So we'll go ahead and import that. So that's going to be our broadcast. And when we import the broadcast function, instead of basically going ahead and awaiting WebSocket.send, this time we shall say broadcast. And then we shall send a list of connections. So we have to create that list of connections. So I'm just going to create a variable called clients, and or let me just even call it connections. So for each of the connections that will be added, or for this connection or WebSocket that will connect to the server, we'll go ahead and just connections dot add, or I think this is going to be connections.append, then I'll add the WebSocket. But we'll have to initialize this as a list. So I'll go at the top right here outside our function and just simply say connections. So that will be an empty list. So that means that at the start we have a connections list, and for each WebSocket that comes into our server, we shall add it to that WebSockets list using the append function right here. And when it's done, we can then broadcast our message to all the connections. Now the second argument we have to provide here is of course the message, which is our message data right here. So that means that whenever we send a message from either client, we have to receive that message on any other client that is connected to the same server. So I'll do a little bit of spacing here and save. Let's restart our server. So I guess I'll have to terminate that terminal and then restart it again. And that will show us the WebSocket server running on that specific URI. When we go back to our chat client, this time when we refresh, we shall see that this is connected. If I refresh, this one will also be connected. But the difference this time is this client will connect, yes, because it's the first to connect to the server. But when the other client connects, we see the message being sent right here, showing that we can now send messages in between these two clients, and both of them will be in position to see the message in real time. So let us say hello to the other client. Can just copy the client ID right here and send. So when we send that, this time we see our client receiving that message, and then this can say hey, and then we can go ahead and basically send the message to the other client, which is received in real time. So these two chat clients can be in position to receive messages in real time. And to see that happen, we can just say, hey, I send, this is going to receive the message at the same exact time. So that's a very simple WebSocket chat that we've implemented right there. At this point, we've been able to look at how we can send data from the server to the client and from the client to the server by using this simple function or method called send. Now, there's also another important method called close, which will close any connection that we shall be having with the server and the client. So for us to close that, we'll just come on our WebSocket object and call something like ws.close. So that alone will be helping us to close the connection. Let us just try it out. So I'm going to open up the browser tools right here. And what I'm interested in is the console. So I want to see what will happen in case we send a message to our server. If I send this message, hello, and send, we now see that our connection event or our close event is the one that is going to be called. So this time, all the code that we execute when we close the connection is one we shall basically go ahead and execute, which means that that is a very important method that you can use in case you want to terminate the connection given any scenario. Now, another thing that we need to access on our WS object is going to be the ready state. So ready state is another important attribute on our object because it allows us to understand the state of the WebSocket connection at each stage in the connection. And let me explain how that works. It is an integer value, but each of the integers represents some state in which the WebSocket client is or the WebSocket connection is. Let us understand that in detail by going back to our JavaScript. So right here is the different integers to show the different ready states. If we console log these ready states at any time within our connection, we shall see a different value being logged. So let us go ahead and try doing that. So when the server has connected, or when, let's say, the connection is established, we want to go ahead and console log the ready state. So I can do something like console.log. And at this point, I'll do something like ready state. And then I will provide the ready state. So I'll say ws.ready state. I'm going to do this for each of the stages. Let's say for the first stage where we are not listening to any event. Then the second stage when we have opened. The third stage when we get a message. So I'll do the same thing right here. And then the next stage where we are actually closing the connection. I want to just show you the different ready states our client will be or our WebSocket will be in. So yeah, this is basically what will happen. If I were to go back right here, we shall see that the first time we run or access our ready state, 0 will be returned, meaning that at that point, the connection will be just being established, or the WebSocket client will be connecting to the WebSocket server. Next, we have this open connection. So when we finally connect and establish the connection, that value will change from 0 to 1, meaning that the connection will be established and therefore data can be transmitted in between the server and the client. And that's exactly what will happen. And even when we send a message, still our ready state will be 1, meaning that at that point we can share information or messages between the server and the client. Now, for us to be in position to access this tool, we have to find some way of closing the connection. Now, this ws.close will basically change the value from open to closing or close depending on how fast or slow things are. So let us try to close the connection. I'll try to send a message because we have this being called where we trigger the submission of the form. So I'll just try to provide a message in here, hello, and then send. And now we see that this will change from 1 to 3, meaning that our connection is closed. So that alone will show us that the state of the WebSocket will change from 1, where it was open, to closed where it was closed. So we cannot be able to see the closing because this is a little bit faster compared to where we may be in position to actually see the connection being closed. So what we've so far done is to see the status when we've established the connection, the status when we have opened the connection, when we are closing the connection, and when we have completely closed the connection. So these integers can be very important in case you want to run code at different stages of the WebSocket connection. And these are very important. If you want to execute code at different stages, these integers will be very important, and you can access them via the WebSocket.readyState attribute. Now, the interesting thing is we can also have the attributes themselves as we can have the ready states as attributes. For example, we can have the open, and then we can have ws dot closed, and then we can have ws dot closing, and then we can have ws dot. So this is open, closing, closed, and connecting. Now we can even try to console log this out to see what they are actually returning. If we try to, let's say, console log ws dot connecting and save, this time we want to see, I think we are going to just see 0 at the start, which is for connecting. So these are basically properties that will return the integer value of each of the states in which the WebSocket will be. So instead of using the integers directly, you can just access them via ws.connecting or closed or open and so on. And those are very important. So yeah, we've at this point implemented a simple chart to demonstrate WebSockets. You can feel free to go ahead and view more information about each of the attributes that are present on each WebSocket object that we create. Now, for our second example, we have our real-time graph implemented using the Apex Charts JavaScript library. So this is a simple line graph with different data, and it is basically updating that data using values that are coming from the server side. And this can be implemented using WebSockets. So we can have the WebSocket server just sending out data at different intervals to the client, and then the client will just automatically be able to change and display different values on the graph based on what it has got from the server. So when I go to our console right here, and I go to the console, I have different logs for the different data that is being sent from the server. So I'm going to be showing you how I came up with this. All I have is sort of like the same implementation we had in the last video. So this is the front-end client right here, but the back-end client is going to be the real-time graph server right here. We just basically have the same functions. We have the first function being the handler function. It does the same things, get the WebSocket ID, and then creates the random sample of values to send to the client. And then we shall just delay the client so that we do not just send data out in a very fast way, because this can be fast and different values can be sent, and it will make our graphs run a little bit faster. So what we do is to just basically make our server sleep for some time, and then we send information to the client after each of those sleeps. So once that is done, we then serve the function. So what we're doing is just to generate some dummy data from the back end, and then use our server to serve that data to the front end. Now on the server, I've been able to just basically generate data that is in this format, which is our series data. Basically 9 integers, and these 9 integers have to be sent out with different values. So to initialize it, we begin at 0, and then use this Apex Charts library to implement the graph. So how it works is we create a new Apex Charts instance, then we point to where we want to render that graph, which is basically this div with the ID of graph. And once we've done that, we then provide the different options, which include the chart type, which is a line chart, and then the series data. So in this case, we kind of create the name of the data, which is sales data. So I grabbed this from the example, but this is the sales data for 9 months. So then we have to provide that series data. So the series data is what we initialize to 0 at the start of the graph. And right after we've done that, we can then create the 9 categories. So this is the x-axis right here. So these are the different values we shall see right here. So on the x-axis is the data for the different values you may want to show for maybe the 9 months we are displaying data for. And then on the Y is the different data that's coming from the WebSocket that will be plotted. So that's exactly what we are having right here. If we to go back this side, go back here and show you guys. So what we are doing is to create a new connection to our WebSocket server. That's on localhost 8003. And right after doing that, we are then listening for any messages sent from the server. So in this case, we just have information coming from the server to the client so that we can update the client. So each time we send data to the client, we are passing it, and when we pass it, we then just have to update the chart with that new data. So instead of having our initial data, which is 000, we shall then have the new data that is coming in this format. So if I go back here, this is the format that we are actually getting. So each time we create, or each time we get this data, we then just have to update the UI just like you see right here. So that's also a very important example I can show of WebSockets, and I hope you guys have got it. In this video, we've discussed WebSockets, what they are, and how to implement WebSocket servers. We've also seen how we can implement very simple clients on the front end to allow us to work with WebSockets. There are very many things I could say about WebSockets in this video, but for the length of the video, I have decided to just leave you a link down in the description to the WebSocket handbook by the guys at Ebly. I think that book does a really good job at introducing WebSockets and also helping you understand advanced concepts that are involved when using WebSockets. So I'm going to leave it down in the description for you guys to watch. Another thing I like to say is that WebSockets are not a replacement for HTTP. Both of them have different cases in which they shine. For example, HTTP is used in things like REST APIs, and those allow us to get data, not in a real-time way, but they help us to be in position to get data in its current state. We do not need real-time updates. On the other hand, we have WebSockets, which can be very helpful in case we need to implement. In case we need some real-time functionality, like let's say getting the latest price updates, or getting the latest sports updates, or getting something real-time like data from a sensor or something of the sort. So either way, it is very interesting if we all learn WebSockets. Again, thanks for watching, guys. If you've enjoyed this video and want to support me, the easiest way you can do that is through the like button. Please click the like button as it helps the videos get into the algorithm. Also, do not forget to subscribe because that also helps the channel. Support me on things like buy me a coffee for less than $5, and you can also consider becoming a member to the channel. I appreciate all the love and support you guys show me despite my inconsistency, and I promise to at least work on that starting from this video. Thanks for watching, guys. Have a great day, evening, or wherever you are. Bye.